That was really good. So there's a joke among my friends, my coworkers, that I really like milk. I drink every time I wake up in the morning, and every time before I go to bed, I do drink a glass of milk. But no worries. Today, I'm not gonna be talking about milk. That can be another day. But I wanted to portray that this milk jug has a comparison with a lot of like daily products that we use every day, from the toothpaste that we used this morning to even the shopping bags that we use at the grocery store. And the comparison is that this is made of this macromolecule, this polymer called polyethylene, which chemically, this is the chemical structure, how it looks like. But we can envision this as a long string of polymer of balls attached to each other, which compose of the polymer. But what is a polymer? A polymer is just a large molecule composed of long chains of the repeating structural units. I wanted to introduce you guys to my grandmother, Malfida. So my family immigrated from Italy to Venezuela after the Second World War, and I wanted to introduce you that my grandma would invite all of the families that immigrated from Italy into the house, and she would just invite them for the cookout. But something that I would love to tell my grandmother is that we can think of polymers, polyethylene specifically, as plain spaghetti noodles. And these plain spaghetti noodles, once we start adding the sauce, the parmesan, the basil, all those good things, that is what is composed of this milk jug that we have right here. So polyethylene, nature has made a beautiful molecule. It's so cheap. It's about 10 cents for the pound to make it. It's durable, and it's very chemically stable. But another thing that nature made is that anything that's easy to make, it's so hard to just dispose it. So polyethylene, this plastic waste, introduces the long-lasting waste, it's hard to recycle, and sometimes in a very hot day, it's prone to low temperature resistance, so that's the problem of microplastics that we see in the environment. So this empty milk jug, unfortunately, its end-of-life fate, as we know it, it's probably gonna end up in a landfill or even our bodies of water. So we're trying to see how we can start thinking about innovating the plastics recycling industry and how we can tackle this problem, because we need to start acting before we head to bigger problems globally. And when we start looking at data, even though recycling companies say that polyethylene theoretically can be recycled, only 9% only gets recycled. So we think this gets recycled. So I wanted to show you two specific lines. In black, it's what's getting wasted. In blue, it's what's getting recycled. And this is where we're at right now. And this is where we're headed towards 2050. So the current recycling methods, they're not just good enough to eliminate this plastic waste, which is just gonna continue to increase. So current recycling methodology is just looking to just getting this deformed waste plastic milk jug, which is just gonna be deformed after post-consumer use, contaminated. And it's just gonna be broken down, which is a process called depolymerization, which is just gonna be broken down into its building blocks, just called the monomers. And then when we attach this back together, it's a process called polymerization. So when we're putting those monomers back into the milk jug again. But the problem is that this is very hard. It's very expensive. It acts contamination. And it just reduces the quality overall of the milk jug when we put it back again. And plastic waste is just very difficult to sort. So our lab is interested in looking how we can imagine the polyethylene, and what if we just add building blocks? What if we just hammer some sites of change to just do chemistry on these macromolecules of these polymers? So what if we actually didn't break it? And recycling methodologies can be constructed into 3 different categories. So if we take this plastic milk jug or a plastic water bottle, and we just break it down to something of less value, that's called downcycling, and that just reduces the properties and overall making it a worse polymer than it started. If we remake the material, it's just called a closed loop circularity. But we're interested in something called upcycling because this is overall a better process. We're introducing more value, and by tackling the plastic waste, we're introducing an economically friendly approach to transforming this waste plastic and creating innovative and creative strategies to reducing the pollution in our environment. So as a synthetic chemist, we're very interested in looking at chemical reactions and asking questions to successfully isolate and yielding these functional polymers. But I wanted to envision this as, imagine going through this. If we take plastic waste, we add these sites of building sites, and then we do chemistry to yield functional materials compared to polymers such as polyvinyl chloride, which we can just see them as PVC piping at your local shelf at a Home Depot. So what if we just turn this plastic waste and we just give it value? So we don't want to break this milk jug down. We want to put value into it. So we don't want to break it down to a monomer, but in theory, we want to take this milk jug and make it into a chlorinated plastic or another functional plastic and see how we can yield these milk jug going into these chlorinated plastic materials. And the chemistry overall, we're looking at an upcycling perspective, which could finally introduce a circular plastics economy and adding value to our plastics and tackling this global issue. So if I were to talk to my grandmother, I would tell her that we would take this same milk jug right here, add these building sites in red, and we could yield different materials that could correlate to the food container that she could give me some pasta in, the cheese wrapping, even the meat wrapping, or even the soles of our shoes. And with these building sites, we can introduce functionality with the tools of organic chemistry, which are so powerful, and we can yield functional materials and add value to these plastics. So instead of seeing this plastic milk jug in the bottom of our oceans, with the chemistry that we're looking into, we want to see if we can reintroduce it into the shelves with higher value towards a new tomorrow. Thank you.